morning friends, I welcome you all in this session. As you are aware, in previous session we discussed couple of exercises related to measures of central tendency and measures of dispersion. We have also seen what is Z score, and apart from Z score we have seen what are different population parameters. And what are the population parameters? Population parameters are mean, population variance and population standard deviation. So, let us move on to today's session. It is on numerical descriptive measures, and we will see couple of insights about normal distribution curve. So, the empirical rule approximates the variation of data in a bell shaped distribution. So, this is your bell shaped distribution. Now, it has got certain properties. The first thing is, this is middle point of it, and this side is 50% and this side is 50% area. So, area under curve is 100%, or we will call it its unity, right, just 1. Now, this is your population mean, you are denoting it by mu, and this is your standard deviation sigma. So, we will say that approximately 68.27% of the data in bell shaped distribution fall within one standard deviation, plus minus one standard deviation. So, this is plus minus one standard deviation. Now, if I ask you a question, what is this area, right, from mean to 1 sigma towards left. So, how would you find out it? Just think for a while. We are aware that this area, this total area is 68.27. So, the 50% of this would be 34 point, let us say 135, is not it? So, this is area within one standard deviation. Approximately 94.45 of the data in the bell shaped distribution will lie within 2 standard deviation. So, mu plus minus 2 sigma. Again, if I ask you to calculate this area, then what it would be? It would be 95.45 divided by 2, right. Similarly, approximately 99.73 data points would lie in within 3 sigma limits. Okay. So, this is empirical rule, and it has got several advantages. Let us take one example wherein we have applied empirical rule. Suppose that the variable maths set score is bell shaped with mean this and standard deviation. So, how would you draw this? So, this is your distribution, this is mean 500 and this is your standard deviation 90. So, we will say that 68.27% of the test rankers, those who have appeared in test, would score between 410 to 590. How did you get this? Very simple, 500 plus minus 1 into 90, right, 90 is your standard deviation. Similarly, within 2 sigma limits, or when the area is this, you will have 500 plus minus 2 into 90, right. So, this is 380 lower limit and upper limit is 680. Similarly, 500 plus minus 3 sigma, right, sigma is 90. So, you can find out how much how many data points lie within 1 sigma, 2 sigma and 3 sigma limits. Now, apart from empirical rule, there is one more theorem, it is called Chebyshev rule or Chebyshev theorem. Now, one of the assumptions or one of the properties of normal distribution, or what we have seen here, a bell shaped distribution, is that the distribution is normal, then only these work, right. 68.27, 95.45, 99.73, all these are true when your distribution is normal, but in real life situation most of the times you will not have normal distribution. So, if distribution is not normal, then according to Chebyshev rule, at least this much percentage of values will fall within k standard deviation of the mean. Here k is ranging from 1 to any other number, right, 1, 2, 3, 4 or whatever it is. So, let us look at how many data points lie within 2 standards deviation. So, this 1 minus 1 upon 2, k is equal to 2, right. So, we will say that within 2 sigma limits 75% of data points lie. What was the case in earlier example where we had normal distribution? It was 95 point some 4 point, right, approximately this much, but here it is only 75%. When k is equal to 3, so put k is equal to 3 in this equation, you will get 89%. So, 89% of the data points will lie within 3 sigma limits according to Chebyshev rule, and according to our empirical rule where the distribution was normal, it was approximately 99.73, right, but here it is 89%. So, there are some other ways in which we can describe our numerical data. It is called exploratory data analysis, it is called EDA. It includes quartiles, 5 number summary and the box plot. Now, we will see these exploratory data analysis tools. So, let us look at quartile. What is quartile? In fact, in one of the classes I have already defined. So, if you divide your data into let us say 10 equal parts, then each part would be a decile. If you divide data into 4 equal parts, then each part would be a quartile. If you divide data into 100 equal parts, then each part would be a percentile. So, quartile split rank data into 4 segments with equal number of values per segment. So, let us look at this. So, the first quartile is Q1, which means 25% of the data points one side and remaining 75% of the data points other side. Q2 is just middle point, right, or it is median. So, 50% of the observation one side and 50% of the observation other side. Okay. Now, only 25% of the observations are greater than third quartile. So, this is your first quartile. So, 25% of data, second quartile this side 50% and this side 50%, third quartile this side 75% and this side 25%, is not it. So, we need to find out the location of these quartiles. So, the first quartile is n plus 1 by 4. So, n is how many? N is number of data points in your data set. Let us look at second quartile, it is just 50%, yeah. So, just n plus 1 by 2, right. So, just this when you are dividing it by 4, it means 25%, when divided by 2 50%, when it is 3 by 4 it means 75%, is not it. So, this is how you can calculate positions. Now, we calculate the ranked position by using the following rules, right. Now, there are these 3 rules. So, if the result is a whole number, then it is called ranked position to use, right. But if it is fractional, and fractional is like this 2.5, 3.5, 17.5, 95.5 and so on. So, if the result is a fractional half, then average is to be taken of the two corresponding data values. If it is not fractional half, any other number, then round it to the integer value towards higher side, towards positive side. Okay. So, this how you can calculate these quartile positions. So, let us solve this example. So, this is a case wherein there are 9 data points 11, 12, 13, 16, 16, 17, 18, 21 and 22, right. So, the first quartile is what? It is n plus 1 by 4, right. So, n is 9. So, this is 10 by 4 is 2.5. So, what we have said? It is 2.5, right. So, fraction is 1/2, right. So, we have to take the average of these two, right, 12 and 13. So, the Q1 is 12.5, right. Okay. Why did we take average of these two? Because the result is a fractional half, right. Let us look at how to find out Q2. So, before this let me tell you that Q1 and Q3 are measures of non-central location. Of course, they are not central location. In fact, Q2 is a central location, is not it? Let us find out what is Q2, right. So, Q2 is what? N plus 1 by 2, is not it? So, this fifth position. Fifth position is what? First, second, third, fourth and fifth. So, this is Q2, which is also median, right. Q3 it is n plus 1 by n plus 1 into 3 by 4, right. So, this is 7.5, again fractional half. So, we have to take the average of 7th and 8th data points, right. So, first, second, third, fourth, fifth, sixth, 7th and 8th, is not it? 18 plus 21. So, this is 19.5. So, we will say that Q1 is this, Q2 is this and Q3 is this, right. So, this is how you can find out quartiles. Now, one of the important measures of dispersion is range. So, you can though range is not a good measure, because it takes into account maximum and minimum value, but there is something called interquartile range. Now, interquartile range can be calculated like this. This is the difference between Q3 minus Q1. In other words, the middle 50% of the data. So, let us say this is your distribution, right. So, we will say this is your Q1, this is Q3 and this is your Q2, right. So, we will say that middle 50% of the data is interquartile range, it is called IQR, right. IQR is also called the mid spread because it covers middle 50% of the data. So, you can call it either IQR or mid spread. IQR is a measure of variability that is non-influenced by outlier, most important characteristics of IQR. Why? Because it is not affected by outliers or extreme values. Why not affected by extreme values? Because the extreme values would be somewhere either in this Q1 part or in less than Q1 part or this more than Q3 part, right. So, that is why it is not influenced by outliers. So, measures like Q1, Q3 and IQR that are not influenced by outliers are also called resistant measures. So, you call them and you can call them resistant measures as well. So, let us look at this. If we want to find out IQR, as I said, it is middle 50% of the data. So, let us say you have got a data set and in which the minimum value is 12, maximum is 70. and you have found that the Q1 is 30, right, Q2 45, Q3 47. So, how did we find Q1? It is just 1 by 4, right, n plus 1 by 4, right. So, after putting n here in this formula, we calculated Q1 and Q1 was 30, right, Q3 57. So, IQR would be 27, right. Difference between Q3 minus Q1 is IQR. So, this was about quartile. Let us move on to 5 number summary, right. So, what we are discussing? We are discussing exploratory data analysis tools. So, we have seen quartile. The second one is 5 number summary. Now, this is very simple one. 5 number summary means there are 5 numbers which would be telling us about shape of the distribution. So, this is first number smallest, the last one is largest number in a data set, Q1, Q2 and Q3. So, these are 5 numbers. So, that is why it is called 5 number summary. Now, if you look at these 5 numbers, then you will be able to know where data are concentrated in a distribution. And there is a relationship between 5 number summary and distribution shape. 5 number summary and distribution shape. So, if you look at this distribution shape, for example, so this one is right skewed distribution, right. This one is left skewed or negatively skewed, or this is also known as positively skewed. This is symmetric data, right, perfectly bell shaped curve, right. So, let us find out relationship. So, we will look at only for right skewed distribution. So, what is the relationship? Whatever is median, if you subtract smallest value, then that would be always less than largest value minus median. So, this is the relationship. The second relationship is whatever is your Q1 value, subtract smallest value from it, that would always be less than or equal to largest value minus Q3. So, this is another relationship. The third one is median minus Q1 will always be less than Q3 minus median. So, these are 3 relationships for right skewed distribution. Similarly, you can have 3 for left skewed and 3 for symmetric. Okay. But you need to know what is right skewed distribution, right, or positive skewed distribution. Keep in mind that when you say positive skewed, so this is your distribution, let us say, this is your 0 point, this is plus 1 plus 2. So, I can have like this, right, this minus 1 and minus 2, right. So, since this tail is skewed towards positive side, that is why we are calling it positive skewed. Okay. 5 number summary and the box plot. So, this is your 5 number summary, right, smallest value Q1, Q3, median and largest, and this is the box plot. In box plot, what you will have? All these 5 points, right, smallest value, largest value, Q1, Q3 and median, right. We have always said that this Q1 is first 25% of data, median first 50%, right, this is the middle point, and Q3 first 75%, right. So, this is box plot. Now, the shape of the box plot will tell you how data are distributed. Let us look at this box plot. So, if your data are symmetric, then the box plot and center line are centered between the end points, right. So, this is your box plot and this is your median. So, this line would be in center of Q1 and Q3. It means it is a symmetric distribution, right. A box plot can be shown in either vertical or horizontal position. So, you can have a box plot like this also, right, is not it. So, this is your, let us say, largest value, this smallest value, largest value, smallest value, this is your median. So, you can have, this is your Q1 and Q3, right. In fact, Q3 should be towards largest value. So, this is Q1, this median, and this is Q3, right. So, you can have a vertical box plot as well, but you have to see this point very carefully. If this is towards Q1, then it would be a positively skewed distribution. If it is towards this, it would be a negatively skewed distribution, right. Just see, this is box plot and this is your right skewed curve, right. So, this is your box plot, this is your Q1, this is Q3. So, and this is median, right. Since this is towards Q1, so it is right skewed. Now, here if you look at this, this is towards Q3, so it is left skewed, and of course, in case of symmetric it would be in the middle of the box plot, right. So, this is how there is a relationship between box plot and distribution shape. Let us look at one more example. In fact, apart from knowing what is the shape of distribution from box plot, you can get one more information, and it is whether how many points are outliers, or which points are outliers in a data set. So, that can also be known from IQR, from interquartile range. So, here you have got some data points. So, you can easily draw box plot. So, let's see how to calculate outliers in a data set. So, there are multiple methods, but the very first method is using IQR, or interquartile range. So, a value is considered an outlier if it is more than 1.5 times the interquartile range below Q1 and above Q3, right. So, Q1 minus 1.5 times IQR is nothing but those data points would be outliers. Similarly, Q3 plus 1.5 IQR would be, now all those data points would be outliers, right. Let us look at this example. So, we have to find out outliers. So, here you have got how many data points? Let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, there are 40 data points, right, and we have to find out outliers. So, first of all, what you need? First of all, you need Q1 and Q3, right. So, Q1 is this 8100, just see, is not it, and Q3 is this 12900. What is median? 10,000, right. So, IQR is what? Q3 minus Q1. So, this is 4800, 4800 is IQR. So, first of all, you have to take 1.5 IQR. So, 1.5 IQR is this 7200 is 1.5 times of IQR. So, what is the outlier? I have said Q1 minus 1.5 times IQR. So, all those points which are below this would be outliers. So, just see, this is Q1 minus 1.5 IQR. So, Q1 is this 7200. So, all those points which are less than or equal to 900, they are outliers. So, is there any outlier over here? Is there any data point which is less than or equal to 900? Yes. So, these two are outliers. Okay. Now, in fact, you just keep in mind that for finding out Q1 and Q3, first of all you need to arrange data in ascending order, right. I think you know this point. Q3, let us look at the outliers towards higher side. So, Q3 minus 1.5 times IQR. So, this is 20100, 20,100. So, all those points beyond this or more than this would be outliers. So, is there any data point? Do we have any data point which is more than this? Yeah, it is there, they are there. So, these three are outliers, right, is not it? This is 20,300, 21,310 and 21,315. So, these three. So, in this data set how many are outliers? Total 2 plus 3, right, 5 outliers, right, 2 plus 3. Okay. Before moving on to next slide, let me summarize what we did today. In today's session, we have seen empirical rule for normally distributed data, and in which we have said that within 1 sigma limit, 2 sigma limit and 3 sigma limit, you have got approximately 68.45 data, 95.45 data and 99.73 data. We have also seen Chebyshev rule, and the advantage of Chebyshev rule is that it can be applied to non-normal distribution as well. So, if you look at let us say mu plus minus 2 sigma, then approximately 90% of the approximately 89% of the data set would lie in 2 sigma limit, while in case of normal distribution that value was 95 point something, right. Then we have also seen exploratory data analysis tools. We have seen quartile, we have seen 5 number summary, and we have also seen IQR, right, and box plot. So, what is quartile? It is basically you are dividing data set into 4 equal parts. So, for IQR or interquartile range, you need to subtract Q3 minus Q1, which is also known as the middle 50% of the data set, which is not influenced by outliers. And we have seen box plot and 5 number summary. In 5 number summary, we have seen largest value, smallest value, Q1, median and Q3. And what is the use of box plot? What does it give? What information does box plot give? It tells us whether data are normally distributed or positively distributed or negatively distributed, just by looking at the center value of the box plot, right. So, let us say this is Q1, this is Q3. So, this would be, if it is exactly in center, then it would be normally distributed data. And we have seen how to find out outliers. So, Q1 minus 1.5 times of IQR. So, those values which are less than this would be outliers, and Q3 plus 1.5 times of IQR, all those values more than this would be again outliers. So, with this let me finish today's session. Thank you very much.